Right, good afternoon, Stefan. My name is Stefan from Western Digital. I run the smart video recording segment under Eric, who presented a little bit earlier. Smart video to us includes essentially what formerly was known as the surveillance business, right? And we sort of rebranded our internal division as well because today it's no longer just about surveillance or security. We're seeing a lot more new use cases coming up. Smart transportation, smart cities, and we're actually seeing the market shifting in that direction, meaning the market is actually shifting to position not just as a surveillance solution, but also to these newer smart use cases. So I want to talk today a little bit more about, how big is this market? What are we offering today? And what are we doing that's so unique to address
Smart
this?
use cases means that the camera are smarter. I mean, there is some CPU in the camera doing AIs kind of stuff.
That's correct. Yeah. So I'll walk you through that, what the architectural changes are that we're seeing and what we are predicting moving forward. So indeed, today it's primarily focused on the edge, right? If you look at where our business is today, we sell a lot of our consumer or client drives, or not consumer, client drives at the edge in NVRs and DVRs. And so we're now looking at expanding, and you'll see some opportunity there now that we have a full portfolio of storage capabilities. Before I start, I wanted to share a couple of numbers because it's always interesting to see how big this market is. So first of all, a lot of it is depending on the number of cameras that are being shipped. Just last year, we had close to 600 million cameras that were actually shipped. Of those, 1 out of 5 was a network camera, which is great. And it's primarily driving not just wireless cameras, but also it's driving those newer video as a service workloads, so cloud workloads that are being deployed right now by our customers. Second, a lot of data gets generated. I don't have to tell you that, but it's always good to see a number there as well. But the third one here is where we are playing today. So it's a $2 billion market just at the edge, where we have a majority share. So we, Western Digital, have a big share in this market because there's only like 2 main players. That's Western Digital and Seagate. And I'll talk a little bit more about where we position our drives and what's so unique about that. In general, what's interesting is that for CY20, there's an expectation that this market is going to grow by 27% in exabyte, which is humongous, right? Obviously, we'll see, but it's undeniable that this market is a growing market. So we've been in this market now for 6 years. This will be our 7th year, for those who don't know, but we've been selling the Purple drive, which is our dedicated, tuned drive, so firmware optimizations are done to optimize for this type of workload, and we've been selling multiple exabytes in this space. Just last year, tens of exabytes have been sold in this space, and we support an edge-to-core architecture. So when we talk to our customers, we can talk about micro SD, eMMC in the camera, all the way down to large JBOD configurations in the data center. We have more than 100,000 integrators today that sell our stack, unique integrators over the last 6 years that have sold our stacks, which it's a massive channel and OEM business. And we have more than 50 ecosystem providers today that we work with directly, specifically to optimize our drives, optimize our stack. So we have a very deep workload understanding, and we have obviously a lab and resources that are dedicated specifically to optimize our storage architectures for these workloads. Obviously, I don't have to explain this, but when I stepped into this market, initially, we all know the video surveillance, right? The video surveillance workloads, we understand why it's being used for. It's to secure ourselves. It's to protect, from theft and other sorts of malicious attempts. But today, the market has shifted, right? So there's a lot more positive, more value-added use cases that we've seen in the space. One is, for example, the use of drones in agriculture, the use of cameras in the factories to optimize quality control. There's examples of people that have been caught with, or some person that was running on a treadmill that was caught with a heart attack, so where they actually could respond pretty quickly on this human being. So there's real value props that can be added or can be provided back to you as a consumer and as an enterprise in this space. One that I want to call out is fleet management, because we're seeing definitely growth in fleet management as well. perfect example is a school bus. Today we have customers that are monitoring school buses. It's fully integrated as a service. What's interesting is that this school bus typically has 11 cameras these days. And one would expect most of these cameras to be outside of the bus. The reality is 8 of those are actually mounted in the bus, 3 outside of the bus. Just to give you an example of how much effort and how much data is being captured, just to monitor behavior, monitor certain things that happen within a certain vehicle. And on top of that, it's not just a rich video content that's being used, but also sensor data that's correlated with that video data. So for example, when a driver is driving too fast, or he's speeding, or he's on his phone, automatically a trigger will be kicked off, and the last, let's say, 3 minutes of video footage will be sent over to the data center, where it's then supervised, where it's reviewed, and action can be taken. So there's a lot of new services that are being built around and are being added in even the enterprise space.
So just a question.
Sure.
With all of these, there's obviously a lot of, and I know this is beyond what the disk can do, but there's a lot of privacy implications to this. And while, there's things even about a driver being triggered to be videoed, how much of that is taking away our rights? Does any of those discussions come up within the product managed development, or do you guys think about any of that, or are you just creating the disk to the designs to create the capture of all that information?
No, it's a really good question. I think if you look at the past, we've been more designing our drives on speeds and feeds, but we're now getting more into the actual use cases. So we're putting a lot of effort in Western Digital now to understand what's the real value prop that we can provide and how can we help, because we're very concerned about the ethical, the human rights situation in general. So the way to do that is by working closer with our partners and integrators as well. The privacy does come up in different ways, meaning some of our integrators are looking at protecting that data. So I'll talk a little bit more about what technology solutions we have. So one in particular is, for example, when you enter a micro SD card, when you have look at a micro SD card, we have ways to lock that micro SD card to the camera itself. So if someone would take out the micro SD card, the data would be unreadable, or you can really read the data from that. So by working and integrating our hardware more tightly with the software stacks, we can also deliver more features back to our customers. And so these conversations, of course, are constantly evolving, but it is something that's come up, absolutely. So what is the other point to that? So, if you look at what's happening in the market, and we sort of you already talked about it, Enrico, right, in the beginning, you're seeing AI and video analytics essentially accelerating the ability to make more decisions closer to the edge. So what we're seeing in general is we're seeing customers wanting to make faster decisions at the edge. And the way they do that is by enabling the cameras and the NVRs and DVRs with these newer machine learning enabled chipsets. That do anything from basic object identification to more advanced facial recognition in the core data center. So I would say today what we're seeing is object detection, identification if it's a dog, if it's a human being, seeing if there's certain behaviors or specific quality checks. And then in the gateway, we're seeing real extraction and aggregation of metadata, so where they really start in doing real inferencing. And then on the core data center, we see deep learning, so where all the data gets consolidated and where they optimize their models and train their models to optimize specifically to their use case. So in the end, what are the four trends that we're seeing? Well, one, it's all driven by smarter value-based use cases. So we're also seeing a shift where some of our customers are more looking at a business case, and they're trying to focus on a specific business case, like providing a service to school buses or optimizing their crops, their yields for their crops. And it's enabled and powered by these newer AI chipsets. And then 5G in certain countries like China and Korea, we see a higher adoption of 5G, and eventually that will come to the US as well. But that will help to stream more data across the network and capture more data back to the core data center. And then last but not least is the storage technology that's shifting underneath it to support that. So we see a lot more flash coming into the camera, higher capacities. And so the end goal is there to focus more decision-making at the edge. Now, how do we see that? How do these architectures change? Well, if you look back 7 years ago, every camera had simply a single stream, right? So if you look at a DVR or an edge gateway, it was just dealing with, let's say, 16 cameras per DVR. So you had 16 streams coming in. It was very easy. We put in a CMR drive, 1 to 2 terabyte, pretty standard. Or back in the day, it was probably 500 gigabyte. Today, it's a lot more complex. So what are we seeing? We're seeing not just an increase in number of streams per channel, but we're also seeing the enablement of these chipsets, and sometimes we use, and definitely in the data center, we're seeing massive GPUs and FPGAs. Now, where we sell our purple drives today is primarily in this space. Where we sell our micro SD card is primarily in this space, of course. Now, what's interesting is that in the gateways, what we're seeing is an increase in number of AI streams as well. So what that means is that these chipsets are now reading back the data. They're doing some processing. They will spit out some result like, I've identified a dog, I've identified a human being, I've identified two people fighting, and so that could trigger a certain event. The reason why this is all important is because today, this business primarily is still HDD. Believe it or not, right? So a lot of these deployments are very cost sensitive. And so we're tuning our firmware, and we've done a tremendous good job in the last 6 years in tuning our firmware to optimize the firmware for these workloads. And as these streams are increasing, that becomes more important.
What is an ML chipset? I just don't know.
Oh, sorry, machine learning. So it's a chipset essentially that comes with some basic SDK that will allow you to feed the video through the chipset, and the chipset will spit out like a result. For example, I've seen a dog in this, this frame, and then that gets tagged and stored somewhere. So what we're seeing is that in the gateways, we're actually seeing databases now as well appear too, that will start to collect that metadata. And the reason why they store these databases there is because they want to make the decision at the edge, which is great. That also means that more storage is actually kept at the edge, and retentions will eventually get longer.
What is your definition of the edge?
Good point. So I think it's constantly evolving, of course, but in this scenario, the endpoints are the cameras. The edge is defined as a series of gateways. I've simplified it here, but you're seeing between this gateway and the video analytics server, you actually have a range of servers. And depending on the capacity requirements, depending on the compute requirements, you will actually see different products appear in this space. So with our ecosystem partners, what you're seeing is you're actually seeing some of the models that used to be deployed only in the data centers are actually now moving closer to the edge. And it's really a cost play. So we're sitting down with them and we're looking at, okay, what capacity can we offer for a certain cost? Now, the fact that we optimize our firmware helps us to get faster to a certain cost profile.
What about security implications then of keeping that data outside of the data center, but having it further out on the edge?
Yeah, a lot of. Yeah, I mean, that's a good point, right? So it depends on the use case. Certain use cases that they don't really care too much. They've been doing it for a very long time in the edge, but more and more also these software stacks will provide encryption capabilities. They will come to us and will say, okay, what can you offer from an encryption perspective on the hardware side? So if someone takes the drive out, or if someone takes a micro SD card out. So we actually, with some of our OEMs, even we lock our drives and tie it back to the device, to the gateway. So if they take the drive out, it will not work in another box. So we're doing certain things with them already. Now, of course, we only have so much control. A lot of it is sort of depending on the software stack that is driving these video management stacks and the actual use case, right? So I have 2 minutes left, but does that, we can. So why Western Digital? So if you look at the trends, right, obviously we're in a really good position because we pretty much have, the full portfolio from embedded, eMMC all the way to large capacity drives in the data center. But what have we optimized at the edge? Well, we implemented health monitoring and guaranteed endurance because for those enterprise customers or these larger customers that really deploy larger projects, they want a certain endurance that's guaranteed, certain warranty that's guaranteed. They don't want to just buy the micro SD cards from the shelf because they will deploy it at scale and they want to manage it at scale. So you don't want to go up you don't want to go up your building and take a ladder to check what the status is of the micro SD card, right? So we actually built health monitoring capabilities that allow them to monitor it through their software stack. So a lot of our effort is actually gone into productizing these micro SD cards in such a way that they can be deployed easily and scaled easily within a larger project. Second is why Western Digital at the edge. So what have we done to optimize our Purple Drive in those gateways? Well, there's a couple of things. One is we've optimized our firmware to be application aware. So we actually work very closely with the ecosystem. So we actually sit down with them. We look at how does the data stream come in? How does the metadata stream come in? How can we optimize it for writes? And then how do we cache? So how do we assign the right amount of DRAM to make sure that we can deliver the right amount of performance, because we need to be able to support 24/7 recording. So that sounds easy, right? You can take an enterprise drive, that's easy. But as those streams are scaling, that becomes a lot harder.
Is the Purple Drive an SSD or
No,
disk drive?
It's a client HDD. So it's a client drive. It's the Western Digital, the original Western Digital drive, yeah.
So is it optimized to, handle vibrations and so on, because since it's out there, right?
Yeah, there's some vibration support as well, for sure.
Okay.
But what we're working with some of the ecosystem partners that create specialized DVRs for like in school buses to cover some of that vibration. The majority of the optimization is really in the firmware. And the value of this is that as we see those customers move into SMR, because we actually have customers deploying SMR, we can now align the writes specifically to specifically so that it's optimized for SMR, so they can get more capacity faster. And because we have that strong relationship, we can move them faster to SMR. So that's a big opportunity for them, because they can give more capacity back to their customers faster, and so can we. Go ahead.
What is the all-frame AI?
It's all-frame AI is really our marketing name for caching. So we basically have a cache area that we use for flushing data. When we see metadata, we could separate metadata. We have more details behind it, but really this becomes more important as you increase the number of streams and put more constraint on the drive. Specifically when you have, let's say, a single drive in a single box with 16 cameras. If you have a box with 4 drives, then that becomes less relevant.
I didn't see anything about your firmware updating message strategy for these things.
Firmware update.
For drives, especially a vulnerability for, is there any requirement for some of these drives to have firmware updates, lifecycle management, like strategies?
You mean after it's deployed?
After it's deployed.
Nothing unique than a normal drive.
Okay.
Nothing special. Typically, when we qualify a drive with an ecosystem partner,
Frozen.
It's pretty frozen. Yeah, it doesn't really need. And then, so last but not least, right? Because we have that tight relationship, it's a lot easier for us to move them to SMR because we understand it, and that gives a lot of opportunity for both of us. So really, my time is up. They've shown me the done sign 5 minutes ago. But we basically have anything from endpoints to clouds. And so in summary, large market, it's growing. We're seeing compute really move to the edge. Capacity is growing to the edge. I haven't really talked too much about the data center side because obviously there's a big opportunity there as well, but that will be addressed by some of my colleagues. And we're seeing transitioning closer to the end from a flash perspective, and we're seeing opportunity on the data center side as well. Right, the SoC, yeah.
How do I get right?
You divide that by 4 for the mainstream. So so let me rephrase the question. So, as these AI streams increase, right? The stress on the drive will go up as well. Yeah. There are certain limitations in some of these DVRs that are limited by the SoC that's used. And so we were talking earlier, there's some 320 megabits per second limitation that prevents some of these DVRs to handle higher resolutions. Meaning you can have a 4K camera, you can have 16 4K camera, but if the NVR, DVR cannot handle because of the SoC, customers won't be able to use that higher resolution. But you have to just divide it by the number of streams. So in this case, it would be, let's say, 4 per camera. You have an auxiliary stream, picture stream, data stream, and playback, let's say. And then if it's an AI-enabled DVR, you will see typically 2 extra streams just to process the data streams on object identification or whatever.
So you're selling separate devices at the moment.
Right.
Don't you think that an hybrid device that includes flash and traditional drives, from
A hybrid device.
A hybrid
an
device.
hybrid device would be a better fit for this market? I mean, you need some, especially now that you have more AI to the edge, so you need some performance and not just the throughput of the of the stream. So
Correct.
more, and I'm thinking more about space concern in this kind of devices. I mean, in the edge device. So
Here, right here.
yeah.
Yeah, I think you're right. So we already have seen some interest there. It all depends on the ecosystem, so the operating system. I mean, not the operating system, but the actual software stack and how flexible that software stack is to tier or, let's say, store metadata on a smaller eMMC device and store the video data on, let's say, an SMR device, right? So we haven't seen the market move that way. What we've seen is the cameras just increase their capacity. So that's been very apparent. And the NVR and DVRs are moving up from, let's say, a 4 terabyte to 6 terabyte. We're seeing growth there. So we're seeing definitely higher capacity. I think there is a point where, as AI will get become more mainstream, because it's not completely mainstream yet, you'll see more, as they reach more scale, you'll probably see more opportunity there for flash. Yeah. And some architectures are shifting already where instead of using an SoC, some ecosystem partners are using a traditional Intel architecture. So I was saying, like, some of these are using a traditional data center approach and are moving it closer to.
And you didn't mention 5G. I mean,
yeah.
doesn't this architecture with the edge device, with edge?
This one.
Yes.
Yeah.
Becomes less relevant in a 5G scenario. I mean, not everywhere, but having the camera directly connected to the cloud.
Yeah, we're seeing businesses pop up, right, that offer video as a service. Absolutely, but it depends from region to region, the connectivity. So actually, what the shift here is that micro SD cards, where they used to be used as a backup for when the network was down, today is used more and more as primary storage. And only the data that's relevant gets uploaded to the cloud. So there's definitely a shift, but to your point, I haven't seen a lot of 5G, really truly 5G enabled regions, at least in the US,
really...
right? So we're still waiting for that to be a reality. But definitely in China, you're seeing faster adoption of 5G. So I'm expecting it to happen there first.